Hello everyone, welcome to my YouTube channel. This is Samuel Olushola here again, and in this video, I'll be walking through the NestJS architecture. My aim is to convince you, if you are a Node.js developer and are not using Nest already, that Nest is the Node.js framework that will allow you to craft robust, scalable, and maintainable applications. If you are already using Nest too, I also hope I'll be able to explain some of the Nest concepts that you might have questions about. It is advisable that you follow along in this tutorial. And for you to do that, I'll be assuming that you know JavaScript and you also know some TypeScript. I'll also assume that you know your way around Node.js. You can install packages with npm or with yarn. If all of these are true about you, then you are in the perfect position to follow along in this tutorial. Even if you don't have all of these requirements and you are just looking to explore Nest.js, you can also follow along as I try to explain the core building blocks of Nest.js in the simplest of terms. With that being said, let us begin. Nest addresses one of the key issues in building Node.js application, which is the absence of a structured architecture. The most popular way to build Node.js application currently is by using Express, and Express.js prides itself as a fast, unopinionated, minimalist web framework. This means that it gives teams freedom to choose the architecture of their project. This can lead to an architectural void, and this architectural void can lead to code that is difficult to understand and difficult to maintain because different teams might have different ideas on how to structure their project. What NestJS tries to do is to introduce an architecture that aims to ease scalability and maintainability. And because the NestJS architecture is consistent across different applications, this means that new developers can quickly grab the project layout and the logic quicker, because when they join a Nest project, they have one less thing to worry about. Now, we are going to talk about one of the core concepts in Nest.js that I believe every Nest developer should understand. You can write your Nest application without understanding this concept, but understanding it, in my opinion, is one of the ways to understand how Nest itself works, and it will help you to debug your Nest application better. And that concept is the dependency injection in Nest. We are going to be talking about what a dependency is and how Nest enables us to manage dependencies properly. To understand what a dependency is, let's imagine that you are a chef and you want to prepare a meal, and you are going to need different ingredients that you combine together to provide the meal. Each of the ingredients, they have different things that they provide for you to be able to prepare the meal. Looking at this in terms of application development, the different ingredients that you need to combine are the dependencies. They represent external resources, services, classes, or libraries that provide specific functionality that you need to combine together in order to prepare your application, which is analogous to the meal prepared by the chef. Now we are going to look at an example of dependency in code. Let's imagine that you have a map service as a class, and you have another service, the Pathfinder, that depends on the map service. This relationship can be represented by a simple class diagram where you have the Pathfinder depending on the map service. We can also see that in the constructor of the Pathfinder, we need to create a new instance of the map service whenever the Pathfinder is being created. This means that whenever the Pathfinder instance is being created, it must be able to find the map service at that point of instantiation because it depends on the map service. We're now going to look at how NestJS enables us to manage this kind of dependencies more easily. We are going to look at the constructor-based injection in NestJS. For us to manage this kind of dependency in NestJS, we are going to transform this class that we have into something like this. Now, instead of the Pathfinder creating an instance of the map service in its constructor, it is only declaring that it needs a map service. Now, NestJS is going to be the one responsible for now injecting that map service whenever it is creating an instance of the Pathfinder. Also, for the map service to be injectable, we need to decorate it with the @injectable decorator from the NestJS common library. This decorator is how we declare a Nest provider. Now that we have gone through a quick introduction to NestJS, we are now going to move to our code editor where we are going to set up a Nest project. See you in VS Code. We are now going to set up NestJS. In order to do that, we first need to install the Nest CLI. We are going to do that by running npm install global at nestjs CLI. So this is going to install the Nest CLI globally. Let's wait for that to be done. Let's wait for that to be done. This failed because I do not have access on this current account that I'm using. So I'm going to run the command with sudo. If you are running this from your root command, then from your root account, you won't have a problem. I just provide my password. That's not correct. Aha, now this is installing. Aha. Now the Nest CLI has installed. To create a new project in Nest, we are going to do Nest new. Let's call it Nest Architecture. And then we are going to enter. So what we provide after new here will be the name of the project. And then we enter in order to create a new Nest project. This is going to ask us what we want to use. I would prefer to use yarn. And this is creating the project and installing all the dependencies that we need. So let's wait for that to finish. Now the project has been set up completely. If you don't want to install the Nest CLI and you want to create a Nest project, you can use npx by running npx at nestjs/CLI. And you run the new command Nest Architecture. This is also going to create a Nest project, but in this case, it is not going to install. You don't need to install Nest CLI on your machine. I have opened the project created with the Nest CLI in VS Code. In the source folder, we are going to see some interesting files here. In main.ts, we have where the application is bootstrapped. We are going to see that the application is created on this line and it listens on port 3000. We have some other interesting files in the source folder, and throughout this tutorial, we are going to learn what these files do. We are now going to look into the app.module file. This is where the root module is defined. Let's now learn about what modules are in NestJS. For us to understand what this file does, let's look at what modules do in NestJS. Now that we have created a NestJS application, we are going to understand one of the first core building blocks, which is the NestJS modules for organization. Nest uses a module-based architecture, and for us to understand the architecture, let's imagine a train that has different compartments and cargoes that each compartment carries. In this case, each compartment represents a module, and each cargo represents the functionality that each module encapsulates. This is how NestJS ensures efficient organization and separation of responsibility. Nest uses a module-based architecture, and each module is expected to act as a self-contained unit that encapsulates related functionality. Let's look closely into the module that was generated when we created our first NestJS application. We can see that this module is just a class that is decorated by the module decorator. This module decorator is how we declare and define modules in NestJS. And we can supply the properties that are used to configure this module, which includes the import, the controller, the providers, the exports. We will now be looking into each of the properties one by one. The import is how we integrate other modules for usability. So for example, we might have a module A that imports module B. That means that the functionality that module B exposes will now be available in module A. That leads us to the export. The export, they define components accessible to other modules. When you have a module and the module defines an export, the export serves as a public API. Only the things that you exported will be available in the other module that imports it. So in this case, module A will only have the functionality that module B exports. Module B might have a lot of functionality, but might expose only a few of them. So that is the only thing that module A will have access to when it imports module B. Now, talking about controllers. Controllers in NestJS are how we manage incoming requests from user. We are going to learn more about them later on in this tutorial. The way that we register controllers is by listing them out in the controllers array like this. The last property here is the providers. We have earlier explained what the providers are, and this is how we register provider with the Nest dependency injection system so that it knows how to inject them. Now that we have gone through a simple explanation of the NestJS module-based system, we are now going to go into VS Code, where we are going to create other modules within the project. See you again in VS Code. Now that we understand what modules are, we are going to create new modules in this project. Let me open the terminal, and then I want to create new module. I'm going to use the Nest CLI. I'll run nest generate module user. This is going to generate a new module named user. We can see that the new module has been generated here, a user module. The configuration is empty. Yeah, we can configure that. And you can also see that when we go to the app.module.ts file, the module has been imported as part of the import of this app module. This is done automatically in NestJS. When you create a new module, it will import it into the Nest upper level module that it can find. We are also going to create another module to illustrate how you would do this if you didn't install Nest CLI. I'm going to run this with npx. So I'll run npx at nestjs/CLI. I'll do generate module. I'll call it orders. This has also generated another module orders, and it is automatically imported in the app.module file. I'll generate another module also. I'll call it the chat module. Chat. Yeah, now we have the 3 modules imported automatically. If we check each of the created files, we can see the modules declared there. This is how you create modules in NestJS. There is also a shortcut to this command. You can do nest generate module user. In this case, G represents generate, MO stands for module. This is a shortcut in case you don't want to type the whole generate and module in the command. Now we are going to the second building block that we want to talk about, which are the Nest providers. The core idea of Nest provider is that they can be injected as dependency, and they include services, repository, factories, helpers, and whatever we need for us to build our application logic, like external libraries. For you to define a provider, you have to decorate it with the @injectable decorator. After defining a provider, you can then create relationships between your classes and objects, and Nest will be responsible for wiring them up. Your classes and objects do not need to worry about how to find a dependency if they are properly set up with Nest. Nest will do that for you. For the providers to be available to Nest, you must always register them if they are to be injected. Now that we understand what Nest providers are, we're now going to create a provider as a service. In Nest, we put our business logic into a .service.ts file, and this service can now be configured as a provider. For us to generate a service, we can also do that from the CLI. I'm going to run the Nest generate service. In this case, I want to generate a user service inside of the user folder. So I'm going to go into the user folder, and I want to call the service a user service. I'll go into the user folder, and the service should also be called a user service. And then I'll pass in flat to create it inside a folder. We now have a new file in the folder, which is a user service, and the file has been automatically imported by the Nest CLI into the user.module.ts file. So we have the service registered as a provider here. Let's go into the user service. It is currently empty, and we can see that it is annotated with the @injectable, which means that Nest will be able to inject it. Now we are going to create some functionality in this user service. I'm just going to copy some code over here. So I'll do that and paste that in. Let me close this. So what we have here, we have a user service, and we have an internal users array. We have methods that gets users, returns the array. We have one that creates the user from the payload. What we just do is we create a new user object. The ID is very simple. It is the time now that we use for the ID. This is just for testing. And also we push the new user to the array, and then we return the new user that was created. Also, we have a method for getting user by ID. It finds the user in the array and returns it if there's a user. If there is no user, it returns an empty array. We need to do this conversion from string to number here because this get user by ID is expecting user ID as a string. So this is an example of a service in Nest.js, and that service is a provider because we said it is injectable by decorating it with the injectable decorator from Nest common. Let's now also remember that for the service to be registered with the Nest, the also remember that for the service to be registered with the Nest dependency injection system, it has to be registered, and that is what is done here. It is registered as part of the providers. Let's look at how to register a provider again. This is how we do it in a module. You provide it as part of the providers array. This syntax of providing a class as part of the providers array to register it is actually a short form for this longer syntax. This is a longer syntax for registering a provider. In this case, we have an object that has two properties, provide and use class. What this does is that it now allows us to tell NestJS to use another class to inject the user service. For example, when we are testing and we want to provide a mock version of the user service, probably because the user service has a lot of heavy computation that we don't want to do while testing, we can use this syntax to do that in our test module. Now we are going to look closely into this syntax of registering providers. We can see that we need to provide two properties. The first one is provide. The value of provide is used as the provider token by Nest, and it is how it identifies the provider to inject. Use class is now how we tell NestJS on how to provide the value for the provider that is identified by the token that we supplied. In this case, we are saying that wherever the user service is requested, Nest should use the class user service to instantiate an instance of user service to inject into them. Providers that we define in this kind of form are known as custom providers. There are also different ways by which we can define custom providers. The first one that we saw is by using the provide and use class. The provide is a token that represents what we want NestJS to register as a provider. It is not restricted to being a class. Then the value of the use class will be a class which Nest will create an instance of whenever the provider is requested. We can also use value by providing a direct value or a reference to an object directly. Instead of asking Nest to instantiate it, we can create the object and supply it as a value of the use value property here. Another way to define custom providers is by using use factory. This enables us to dynamically register providers. So if you want providers that you want to customize, probably inject some other things into it before we provide it, we can also use factory to do that. Now that we have understood providers and custom providers, we will now be going into code and see how we can use a custom provider in our code. In this case, we will be implementing an SMS module that uses an external package to define a custom provider. See you again in VS Code. In order to illustrate how to use custom providers in Nest.js, we are going to be integrating a third-party package, which is Twilio. Twilio is a service that allows us to send SMS from within our application. We are only using Twilio for illustration purposes. It's not like you need Twilio whenever you want to define a custom provider in Nest. To get started, let us install Twilio. We are going to do yarn add Twilio. We are going to add the package. Let's wait for that to finish. After that has installed, we are going to create a new module. We are going to call that SMS module. So we say Nest generate module SMS. So that has created a new module here, an SMS module. We're also going to create a new service. We are going to say Nest generate service. We want to create it inside of the SMS folder and want to name it SMS. We are going to say it should be flagged. I want to name it SMS. So this shortcut G and S represents generate and this represents service. So when I enter that, it's going to create a new service here in the module. It's going to create a new service here and it's going to register it in the SMS module. We can see the new, let me close all of this. And when we open this, we can see the SMS service here. We are now going to create the custom provider for Twilio that we are going to be using inside of the SMS service. To do that, let's create an object here. I'll say provide. It should provide. I'll call it SMS client. I wanted to save this. Uh, Then after providing it, I want to use factory. In this case, I'm not using class or use value. I want to use factory for illustration. I want to use factory for illustration. I'm going to create. I'm going to need to import Twilio here. So I need to do import all as Twilio from Twilio. To use Twilio, we need to call this function that was imported. It will say return Twilio with some values AC. This will be your Twilio account SID. When you register with Twilio, you are going to get that. In this case, because it's just for test, we are not going to go through that. And also, this will be your Twilio account token. The reason I've started this with AC is because the Twilio package checks that the account SID starts with AC. So I'm doing this so that we don't have an error where we need to put AC. But when you're using the real Twilio account SID, it is going to have the requirements that the Twilio package requires. Here, we use factory to dynamically create a provider which the NestJS dependency injection system will inject whenever anything requests for the SMS client. Now, we are now going to go to SMS service and we are going to request for the SMS client to be injected into this service. To do that, we are going to create a constructor. Remember that we define what we want to inject in the constructor. We are going to use the @inject from the next common. It is imported here. And we have to supply the same token that we used to create that we used to register the provider. So we are going to say SMS client, and we are saying that we are declaring as a property private Twilio client. I want to type it so that I can get type inference from Twilio. I will say import Twilio. This is a type from Twilio. Then this will be a type of Twilio. So we have to put as this is a method. Now I want to declare a method here. Async send is going to receive a body and it will return a promise of a string. So I'm going to construct the message the way Twilio wants us to do. Await this dot Twilio client dot messages dot create a message. Then we send it, return. When you create a message with the Twilio client, the message is sent automatically. But here I want to return the message SID, which is an identifier for the message that you sent. Just to clarify, this Twilio client and Twilio implementation is merely for illustration purposes. I'm using it to illustrate how you can create a custom provider where you first register it with a token, and we use factory to specify how the next dependency injection system should get a value for the token. And then when we want to inject it, we use the @inject because it is a custom provider. So this is how you define custom providers in Nest. Let's start the application just to be sure that everything is going well. I was going to say yarn start dev. If there are no errors, then everything is going well. The application starts. That means that the code is compiling. This is how you create a custom provider in Nest.js. You first register the provider and then you inject it specially like this. When you are injecting a custom provider, you must provide the same token that you used to register it, or else Nest will not be able to find it. For example, if I change this to this now and the application restarts, you'll see it complains that it could not find this. You can see it's complaining that it could not find this provider. Let's return that so that it finds it again. What you can do so that you ensure that you don't mistakenly type the wrong name here is to put the tokens here in a special enum. So we are going to do that. We are going to create a folder in the source folder. Let's say call it utils, and we are going to name a file in that folder called custom provider tokens.ts. We are going to export an enum called the custom provider tokens enum, and it's going to have a single value here, SMS client, which is going to equal to SMS client. So now we go into the module. Instead of hard coding the string here, we are going to import the custom provider token.sms client. Rather, so this is what .sms client. We can see that this has been imported by VS Code directly, but I want to change this import to this works. So this has been imported by to this. Now we are importing the custom provider and using it as the provide token. We also go to here and we say, instead of hard coding it here, we say custom provider tokens or provider this way provider custom provider. Oh, customer, sorry. It has to be custom provider token dot SMS client. Yeah. Let me also change this to a relative part. Now we are also injecting with the custom provider token. Yeah, and everything is fine. Good. We are now on to the third building block that I want to talk about, which are the Nest controllers. We are going to look at what Nest controllers are and what they do. For us to understand what Nest controllers are, imagine a ship that is navigated by a captain. The ship represents the client-side requests that are coming from the client, and the controllers are what manages those requests. Just like the captain steers the ship to wherever it wants it to go, the controllers also steers incoming requests to the particular resource that clients are requesting for. So NestJS controllers, they handle incoming requests and return responses to clients. For you to define a NestJS controller, you have to use the @controller decorator from the NestJS common library. Nest also has some decorators for HTTP methods that you will need. For example, if you want to create a post endpoint, a get endpoint, a patch endpoint, you have decorators that will help you define them. We are going to see those decorators in action shortly. There are also other decorators that are provided by Nest, like the @body that allows us to access the body of the request, the @request that allows us to access the request object itself, @params accesses the parameters of the request, and @query accesses the queries that are passed to the request. Now that we have gone through what controllers are, we will now go back to VS Code, where we are going to implement a simple user controller. Again, I'll see you in code. In order to create a controller, we are also going to use the Nest CLI. I'm going to say Nest generate controller. It will go into the user folder and it will be named user. So I run this. If you look at the user folder now, we are going to have a new file controller. The spec here is if you want to write test for your controller, and also the spec for the services if you want to write test for your service. If you look at the user module, you will see that the controller has been registered as part of the controllers in the user module. Now let's open up the user controller and see what we have there. Right now we have an empty user controller. We are going to populate that with some data. We are going to populate that with some functionality. I'll just copy the code over rather than type it. Let's go through what we have here. We are specifying that this controller is for this part users, and we have imported some decorators from the NestJS common. Here we are specifying the user service and the dependency in this user controller. So the NestJS dependency injection system is going to inject the user service when it is creating this user controller. We have also defined some routes. Here we have a get endpoint. This is how you define get endpoint in NestJS. We use the get decorator, and this returns the get users from the user service. We also have a post endpoint for creating user. It reads the body from the request and it sends this over to the create user method in the user service. We also have an endpoint that we can use to get user by ID. Here we specify here that we want to pick the parameter ID. This is how we define a route parameter in Nest.js. And then we access the parameter here. We name it user ID here, and then we pass it to the method that handles getting user by ID in our service. So these are the methods that we have here. Let's start this project and test it out in Postman. So we head over to Postman. We are first going to try to create a user. The endpoint is /user, and we are doing that on the port 3000. I'm supplying a JSON payload with email and password as part of the payload. Now, when I make the request, I'm going to say that a user has been created. In a real application, you should never ever return user password as part of the response. But because this is a test application just for teaching, we are going to leave it alone like this. Let me create another user with another email. Let's say this is and I'm creating another user with another email. We can see that user has been created. Now let's test out the get users endpoint. It is also going to port 3000 and the path is /users. But here we're having a get endpoint rather than a post. When we make that request, we will see the 2 users that we have just created. As I mentioned earlier, you should never return the password in plain text or return it at all in a real application. Let's test out the last endpoint, which is to get user by ID. We are going to copy an ID here. I will come to the get user by ID. We are going to port 3000 /users and we paste the ID that we just copied here. Now we are going to make that request to get user by ID. Now, get user by ID. We now have the response of the user with that particular ID that we provided. As I mentioned earlier, you should never return your user password as part of the payload. Never, never, please, guys. I'm begging you, never do that, please. We're now going into the 4th building block that we are going to be discussing, which are the Nest guards. Imagine you want to host a party and you have a gatekeeper at your gate that either allow or deny access based on some criteria that you have predefined, like say a passcode or a dress code. Nest guards are like gatekeepers. They allow or deny access to routes. For example, you might have a guard that restricts a route to only admin users, or you have a guard that restricts a route to only users that are logged in. So this is how we do it in Nest. We use the Nest guards. For you to create a Nest guard, it must implement the can activate interface from Nest. You can also bind a guard to a controller so that it affects all the routes, or to a particular route handler, or globally so that it affects all the controllers that you have across your application. This is a representation of a Nest guard. You can see that it stands between the user request and your route handler. Let's go into code and implement an admin guard where we are going to use to guard one of our endpoints from the user controller. See you again in VS Code. To show an example of a Nest guard, we are going to create a guard inside of the source folder. You can put this in any folder that you want. I'll call it admin guard.ts. As I mentioned, a NestJS guard must implement the can activate interface from NestJS, and it must also be injectable. So what we do is we say act injectable. This is imported automatically by VS Code. And I'm also going to say I'll define a class called admin guard that implements can activate, which should be imported from NestJS common also can activate. By implementing this interface, we are forced to implement a method defining the can activate interface, which is going to be, let me just right click here. If I see this, yeah, implement. So the method that we must implement is a can activate method, which returns a Boolean. In this case, let me just make it return a Boolean alone. That's what we are concerned with in this project. We are not going to worry about observable. In this can activate method, we have to either return true or false. Let us do that now. I am going to first define an enum for a user role. I'll do that before the, so I have a user role. A user can be admin or user. And what I want to do is I want to define the role for this guard. I'll say constant required row is user row dot user row is user row dot admin. So I'll also get the user. I'll say user is from the context. We are going to switch to HTTP, and then we get the request. And from the request, we are going to get the dot user. After getting the user, we want to check if there is a user, if there is no user rather, or if there is no user, or if the user row is not equals to the required row. If that's the case, that means the user doesn't have permission to pass through this. We are going to return false. But if there is a user role and that user role is equals to the required role that we want, which is admin, we are going to return true. What we do here is that we switch the context to HTTP so that we can get the request, and from the request we get the user that is currently logged in. This will not work now as we do not currently set the user on the request, but we are going to simulate the admin guard working. As I mentioned earlier, you can bind a guard to either the controller, to a method in the controller, or globally. Let's first go through binding it to a controller. I'm going to say use guards, and I'm going to say should use the admin guard. This use guard is imported from NestJS common, and our admin guard is what we defined here. I'll just change this to a relative part rather than the absolute part. Now that we have this, if we try to make any request to the API now, let's say I try to get by ID. Oh, we didn't start the application. So I'm going to do that yarn start dev. So after starting, I'll go over here and try to say, let's say I'm trying to get all the users. You can see now that we are getting forbidden resource because this endpoint now, everything in this controller are now being protected by this guard. And this fails because we are not setting any user to the context. If we want to make this to pass by hard coding it, we are just going to comment this out so that it is always passing. When I save that and the application restarts and I try to test this, you'll see it does not fail now, but we do not have any user as we have restarted the application. And yeah, I can create a user again and I can get the user. So that is how we can simulate the guard working. Now let's try to bind this to just a specific route. Let's say the create user. We are going to, let's remove this here. And I'm going to put it on just the create user. And when we go back to the application and we try to create a user, it's going to return forbidden. Why is that? Because this guard is guarding it. But if you test out the other endpoints, they are still open to use. You don't get forbidden. Also, the get user by ID, you don't get the forbidden response. So this is how you bind a guard to a specific method in a controller. You can also bind the guard globally so that it applies to every controller and every route you have in your application. To do that, we are going to open the main.ts file. Let me remove this here so that it doesn't interfere with what we have. I'll remove all of this also and remove the use guards. Then I'll go to the main.ts file. And after creating the application, I'm going to say app.use global guards. And I'm going to say it should use an instance of the admin guard. We have now binded this guard globally so that it affects every controller and every route that we have. But because we have just one controller here, it's only going to affect this controller. If we go back to our API and we try to test it, you see we are not getting forbidden now because this does not pass. If you try to get all users too, you're going to get forbidden. If you try to create user, you're going to get forbidden. This is one of the ways by which you can globally bind a guard. Another way is to do that in a module, preferably in the root module. So we are going to remove this here. Let me remove what we have just done here. I'll remove this and I'll also remove this. And I will go, let me close everything. I'll go into the app module. And here in the providers, I'm going to register a custom provider. I'm going to say provide. Now the token here is a special token from NestJS if you want to register a guard globally, and that is the app guard from Nest Core. You can see the app guard comes from Nest Core. So you can see that the app guard comes from Nest Core. Then we are also going to now provide a class. You are going to say use class. You should use the app, the auth guard, rather admin guard. Aha. Now we have also globally binded this guard by using a custom provider inside of the root module. If we test it out again, we will see that we are getting forbidden. You should use this approach rather than writing it in the main.ts file. When your admin guard also has dependencies that has to be injected. Let's say, for example, here in our auth guard, we have a dependency that we have to inject into admin guard. Then we have to register the global guard as a provider inside of a module. In this case, we are using the app module, which is the root module. We are now going to talk about the fifth building block, which are Nest pipes for data integrity and transformation. Nest pipe ensure data integrity by validating data or transforming it. They can help us to validate data, to sanitize inputs that we are receiving from the user, and to convert those inputs to the format that we want. Nest has some built-in pipes like pass-int pipe, pass-UUID pipe, and others. For example, the pass-int pipe will allow you to transform a string input to an integer input. If that transformation fails, it's going to return an error response that tells the user what exactly went wrong. The most common way to use Nest pipe is to use them with two packages, which are the class validator and class transformer. We are going to see how to do just that in code when we go to implement validation for the data that we are collecting when we want to create a user in our application. Again, see you in VS Code. We are now going to use Nest pipe for validation. Before doing that, let us remove the guard that we registered here. I'm doing that so that it doesn't mess up when we try to test our application. To see how we can use NestJS pipe for validation, let's go into the user controller. Let's say that in the body here, you want to verify that there is an email and password when the user makes a request. Currently, that kind of validation does not happen. Let's say, for example, I start the application again. Let me start it again. And I go into here and I say, I don't pass password, I just pass a random key, random value. This is going to work as we don't verify or validate what the user is supplying. Let's say I'm in the email here, rather than email, I'm putting in my phone number or a number. Let's say I just put in a random number. We are going to see that this is also going to work. So we want to use Nest to validate the user data that we are collecting. To do that, we will also need to install two packages. Let me stop the server first. I'm going to install two packages, which are the class validator and class transformer. So I'm going to say yarn add class validator and class transformer. Then let me enter this. I'm going to add those two packages into the project. If you are using npm, you can also install them with npm. Now that we have done that, in the user folder, let's create a new folder called DTO. DTO stands for data transfer object, and they are used to define how we want data to be sent over a network. In this case, we are going to be using it to define the schema of the data that we expect from the user. So inside of the DTO folder, we are going to create a new file called the create user.dto.ts, and we are going to define our DTO as a class. So we are going to say export class create user DTO, and I'm going to say we need an email, which is a string. We need a password, which is also a string. Now, this has not been validated yet. We are just declaring that we need an email and a password. We are now going to import some decorators from the class validator. In this case, we are going to say is email, which is imported from the class decorator. This now ensures that whatever the user passes is going to be a valid email. This does the check to do that. And also we want to ensure that the password is not empty. You can see we have different decorators from the class validator package that helps us to validate data coming from the user. There are other decorators that you might need depending on your use case. You can find them on the documentation for class validator. Now that we have declared a DTO, we now need to use it in the controller. So let's go back to the controller. Here, where we are collecting the body, we are going to specify the body to be a type of the DTO. So we are going to type it as create user DTO. Now that we have done that, we will now also go into the service and we are going to type this as a DTO also. Create user. This DTO is automatically imported from the DTO folder. Similarly, in the controller also, the DTO is automatically imported by VS Code. DTO is automatically imported by VS Code. Now that we have included this in the type, the next thing to do is to tell NestJS to validate the DTO. The way we are going to do that is we will go into the main.ts file and we are going to say, after creating the application, we want to say app.use global pipes. You want to use the validation pipe. This is how we tell NestJS to validate those details that we have declared by using global pipes and supplying an instance of validation pipe. Now we are going to start the application and start dev. After starting it, let us test it out. We are going to test out the create user. Now we have the email and password, but this is not a valid email. Let me make the request. We are going to see email must be an email. Now we are getting some messages telling us what we need from the user. So let's say this is Sam Olushola23@gmail.com. You can see that now it goes through. If I remove the .com here and it's no more a valid email, if I try this, it is still going to fail. And if I try to make the request without a password, it is also going to tell me that password should not be empty. This is how we use DTOs and validation pipe to validate incoming requests from the user. Now, we will now be talking about the last building block that I want to explain in this tutorial, which is the Nest exception filters. Let's quickly go through that. For us to understand what exception filters are for, let's imagine we are at a circus and we have some performers that are performing some art, like hanging from a rope. This could be dangerous if the rope cuts and they fall down. So what we have at a circus is a safety net under the performers, so that when they fall on the safety net rather than onto the floor. This is similar to what Nest exception filters do. They catch unhandled exception and return a formatted response to a user. With the formatted response, we might want to tell them what went wrong or what part they are trying to access when something went wrong. An example of unhandled exception is when a user tries to divide by 0 and you didn't cater for that. That might crash your application. But with Nest exception filters, you can have something that will undo those kind of exceptions and return a response that is formatted to the user. By default, Nest has an exception layer that catches all unhandled exceptions and sends an appropriate user-friendly response. This is done by what is called the global exception filter. You can also write custom exception filters and they must implement the exception filter interface from Nest. We are going to see how to do that in code shortly. Just like that, you can also bind an exception filter to a method in a controller, to the controller itself, or to the global scope. Let us now look into the different type of exceptions that can occur in an application when we are building an application. We could have HTTP exceptions, like any exception that will occur between the HTTP connection or communication. For example, if a user is trying to access a route that does not exist, like the 404 exception. We also can have query and database exception. For example, if you're using a database in your application, there might be an error that is not handled that occurs while you're trying to query or trying to put an item into your database. We could also have third-party exceptions. If your application communicates with external resources and if that resource is down, If you don't handle it properly, this might throw an exception in your application. We could also have custom exception that you as a developer defined, and we also have general runtime exceptions, which are errors that just occur in your application. For example, if you are trying to perform an impossible mathematical operation, like trying to divide by 0, that is just like a general exception that your application can throw. With NestJS exception filter, you can define exception filters for different types of exception, or you can define a filter that will catch any type of exception. Let us now go into the code and see how we can define exception filters in NestJS. Let us create a folder inside of the source folder that is going to contain all the filters that we want to create. We're going to call it filters. We are first going to define a filter that is going to catch any type of unhandled exception. So let's call that all exceptions.filter.ts. So we are also .ts. I'm going to copy the code from the Nest documentation. They have an example of that kind of exception. So I'm going to copy it over here. Let's look at what we have here. We can see that the exception class that we are defining implements the exception filter coming from this place. Yeah, which is from the NestJS common. And also what this does here is that it is catching any type of exception because we didn't specify a type here. It's going to catch any type of exception. And in the catch method that we have here, we are getting the HTTP context. And from the context, we are getting the status if the exception is type of HTTP exception. Remember that this filter is catching all types of exceptions. So we are getting the status. If it is an HTTP extension, we are getting the status. If it is not, we are specifying it as an internal server error, meaning it is not an HTTP extension. It is not an HTTP exception. We are also constructing a response body that we want to return when an exception occurs. We want to say the status code is the status that we got from here. The timestamp is when that exception occurred. We are also specifying the path that the user tries to access when the exception occurred so that we can use it to like track or like debug. Before you return the response here, you might be logging your exception so that you can send it over to, let's say, a central log that you can now check when you want to like debug your application. With this done, this is an example of a general exception filter that catches any type of exception. Now let's write an exception filter that only catches HTTP exceptions. In this case, we are going to say HTTP exception, create a new file, .filter.ts. So what the new file does is, let's copy the code over here again. Yeah, the catch decorator takes in HTTP exception, which means that this exception filter will only catch exception that are of the type of HTTP exception. If you have, let's say, a general exception like trying to divide by 0, this exception filter is not going to catch it. Let us now look into how we can bind exception filters. Let's go into the user controller. I'm going to first try to bind it to a particular method. Let me choose this. To bind the filter to a method or to a route in a controller, we are going to use the use filters, and let me bind the HTTP exception filter. Yeah, the use filter is imported from the NestJS common, and the HTTP exception filter is imported from the filters folder that we declared. I'll change this to relative paths. In order to test out this exception filter, let us simulate an exception being thrown. We are going to say throw new HTTP exception. This is from Nest common, and this requires 2 arguments. Let me say forbidden, and I'll now say HTTP status will be forbidden. So yeah, I'm simulating an exception being thrown. In this case, I'm throwing a forbidden exception. I'm getting this status code from NestJS common, so I can use the standard status codes that we have. Here now, if I access the get users endpoint, I should see this exception filter coming into play. So I will start the application again. Yarn start dev. Let it start. So I'll first create a user. Now let me test out the get user. Remember that we have the exception filter here on the get user, and we are throwing an exception just to simulate this. We are now going to try it out. You see that we get a response, and this response comes from the HTTP exception filter that we declared, because we have the paths here, we have the timestamp, and we have the status code, which we define in the HTTP exception filter here. Let us now look at how we can register an exception filter globally. In order to do that, let us open the app module, and in the app module here, we are also going to register a new custom provider. We're also going to provide a token that we are going to get. Is a special token also. It's coming from the NestJS core, just like the AppGuard token. And we are going to use class, which is the class of our all exception filter. Here we have defined a custom provider that is going to bind this our exception filter globally throughout the application. This app filter token is a special token from the NestJS core, which enables us to bind a filter globally. And for us to test this all exception filter, let us go into, let's say, a user controller, and we are going to try to simulate an exception. Let me use the get users endpoint again. In this case, I am just going to throw an error here. Let's say I say throw new error, something went wrong. I'm going to save this. So when I go to this endpoint, the get users endpoint to test, I'm going to see the all exception filter kick in to catch in this error that has been thrown here. So I go to Postman and I make this request. The status code here is 500, and we have the timestamp, and we also have the path as defined in the all exception filter. Let's just look at that again. We are saying that if it's not an instance of HTTP exception, you should use internal server error as the status, which is exactly what we have here. Now we have come to the end of this tutorial. I hope you enjoyed this video. If you did, please leave a like, share, and also subscribe to my channel. And if you also have any NestJS concepts that you want me to tackle next time, please drop them in the comments, and I'm going to look into them in my future videos. Thank you very much for staying with me all through to the end, and I will see you again in my next video. Thank you. Bye.